Yeah. Okay, we're on page 19. So we're going to be talking about how to find area of triangles for specific setups. For those that are in side angle side form or in side side side. I think you'll find this pretty straightforward.
Do I need to get past?
Huh?
Do I need to get past?
I would say that the complexity with side angle side is just that sometimes not enough information is given to you, and we may need to do law of sines to get the information that we need before we can apply the area rule. So those are the more difficult ones, and we'll get to that. This one, I think it's pretty straightforward. We just have to take the time to gather the information. Okay, so spend a minute to copy this down, and I'll go over the rules. We'll practice them, and if we feel comfortable enough, we can move into word problems. Just have an extra day to go through the types of word problems, I think. But we'll probably spend most of the day going over area of triangles. Okay, so again, page 19. Okay, so let's start off with the first formula here. This is, I have triangle ABC shown with side A, side B, and side C, and we know that lowercase side is always going to be across from the uppercase angle. So just really depends on what's given to you. Remember, side angle side is where your angle is tucked in between two known sides, right? We should be able to tell the difference between side angle side versus side angle. Okay. So here's one option. One option is area is 1/2 BC sine A. So if you're only given that information, right, that is side angle side, 1/2 B times C times sine of angle A, right? That's one option. Another option is if I gave you this information here. Angle C, side B, and side A. All right, and that will be 1/2 AB sine of C. And the other option is I give you angle B, side A, and side C. Then it'll be 1/2 AC sine of B. Okay, so we'll practice going through those formulas. If it falls under side angle side category. The other type is if you have side side side. If it's side side side, we have something called Heron's formula. But this is two parts though. Let me draw the triangle that goes along with it. So if it's side side side, what we do is there's a formula, but we first have to find something called the semi-perimeter. Semi-perimeter is basically half the perimeter of the triangle. That's something that's required in this area formula that we're going to use. So the semi-perimeter basically just means adding up the sides of the triangle and dividing by 2. Or you can think of it as 1/2 times the sum of the perimeter. Once you get that S value, then you're just going to follow the formula and enter everything in into the calculator if you like. So whatever that semi-perimeter value is, that comes first. Then we do S minus A. A is one of the lengths of the triangle. Then S minus B, another length of the triangle. And then S minus C. And then all that is under the square root. So really you can just enter all this into the calculator all at once you find the semi-perimeter. Okay. Does anybody still need a minute to copy this down? Okay. Thank you. All right, let's look at number 1. Are we good? Okay, here's number 1. Number 1 says, find the area of each triangle, round answers to the nearest tenth. Let's go ahead and draw the triangle just so that we have something to base our decision of. So I have angle A, side B, and side C. Okay, this is set up as a what? Side angle side, yep. So looks like we can just go through the formula. One variation is 1/2 BC sine of A. Right, and it's just as easy as plugging into the calculator. Okay, so it's round to the nearest tenth. Try in your calculator. You get 85.1. This is area, so I'm just going to give myself a reminder that this is units squared. You don't provide a unit, so I'm just going to call it unit squared. Okay, any questions about how we found those values or how we apply the formula? Okay, so number 2, even without drawing the triangle, we know this is a what? Side, side, side. So we can just rely on the formula that we have. I'll write it. It's a 2-step process. Find the semi-perimeter. And then once you have that, then you can dump it into the formula. Okay, so let's find S first. Okay. S equals 18. We're going to need that for our area formula. Everybody good so far? And now we're just going to enter into our area formula here. Okay, use your calculator and let's see what we get. Okay, what you guys get for area? Yeah, you can either round to 52. I'm gonna say 51.9, but yeah, either is fine. You round to the nearest 10th. That's good. Okay, any trouble with those, 1 or 2? Okay, so let's see if we can practice 3 and 4. 3 and 4 are pretty straightforward as well. One is the side angle side, the other is side. And let's just see if we can get these basic ones down, and then we can look at the side angle sides that are maybe more involved because we may have to use law of sines to get to side angle side. But I think 3 and 4 should be. Just make sure that we are comfortable with applying these formulas.
Would that ever be like a negative value? So I feel like
Right, yeah, so the semi-perimeter is going to be pretty safe. It's always going to be a larger value than any of the sides, so we shouldn't have any negatives. Yeah. So we'll try 3 and 4, and we'll check our answers, and then we'll look at more boundaries.
What's the abbreviation for area? Is that on?
Abbreviation for area. Yeah, I don't have it. Well, you can just say A if you want. Yeah, I wrote it out as area, but you can say
just
A.
such confusing.
Right, they're confusing the thing. Right, yeah. All right, here's number 3. Not even drawing the triangle, we know it's side. Find the semi-perimeter, and then carefully insert into your area formula. All right, don't forget about the square root. Okay, try number 4. Check our answers. Yeah, I rounded to the 100th, but the direction says to the 10th. So 182.9, how about 326.8? All right. Any questions with applying area formulas for side angle side or side side side? Okay. All right, let's look at something that may not be quite set up as side angle side initially. And we may have to use law of sines to kind of get to some of the missing pieces. All right, anybody still need this? Okay. Let's go to the back. Next page, page 20. I think 1 through 4 are pretty straightforward. They're just side angle side or side side side. Let's go to number 5 though. I think 5. If something is not in the form of side side side, then we usually want to just target side angle side. But number 5 is not quite side angle side. What do we need? How about that? What do we need to make it a side angle side? Yeah, one of the sides, right? Because we have enough information, right? Either we can, if we can find side B, then we can do side angle side involving 26. Or if I find side C, then I can involve 132. So ultimately, it really doesn't matter. I think for me, I just arbitrarily decided to solve for B. So let's just do that just so that we can, be on the same page. But if you want to solve for side C, it'll work out as well. But if I want to find side B, how would you set that up? Or what information do you think we need before we can set up to solve for side B? Yeah. And this should be easy, right? Let's find angle A. There shouldn't be any trouble. Anytime you have 2 angles of a triangle, you can always quickly get to that third angle. Okay. You guys get 22 degrees? All right. So how would you move to solve for B? Yep, law of sines.
Rounding to the 10th place.
Let's do to 3 decimal places, just so we can gain more accuracy. I'm sorry. So I think this, these are the ones that are more involved because it's not quite ready for side angle side. So we have to kind of do a little bit of investigation, using law of sines to get to side angle side, and then we can use the formula. Once you have side B, then we're in the clear, right? We can do side angle side involving 6, 26, and whatever side B is.
Are you still asking this again?
Okay, go ahead. Okay, question with 5. Okay, take a look at number 6. What type of setup do we have here? Yeah, side angle, right? So it's not quite set up for side angle side. What we're going to do is we're going to use law of sines to work towards side angle side, right? So we can just use law of sines. Basically, you're just solving the triangle. But you may not have to solve the triangle all the way. Just fine. Just get to the point where you have enough information so that you can plug into the side angle side formula, right? So I feel like if you can do something like number 6, you're not going to have any trouble with these area formulas because you know how to use law of sines to get to the missing information that's needed. Okay, so try that. I'll come around to see if how you guys do. Yeah, so the hint is angle X may not be the one that will produce side angle side. But if you can find X, then you can quickly find another angle that is perfect for side angle side. So and they're not going to get that. So I think the easiest setup right now is to solve for angle X. right? I can say sine of x over 12 is equal to sine of 61 over 16. Okay, you guys get 41 degrees, 40.9 degrees. So this doesn't quite give a side angle side, but how is this helpful? Yeah, if we can find z. If we can find z, then that's perfect, right? Now we'll have perfect side angle side. So I'm going to use the formula area equals 1/2 y x sine z. Okay, so I want us to get more practice with these more challenging ones. I mean, it's not necessarily challenging, it's just a little bit longer, right? You can't directly plug into the formula. We got to use law of sines to get to what we need. So I'd like for us to do a little more practice with this, but any questions with 6? Okay, so let's try number 8 and 9. 8 and 9 are ones also where it's not quite side angle side, but we can use law of sines to move into side angle side. So similar, we're basically just going to kind of hunt for missing angles or missing sides to create that scenario so that our formula can work. Okay, so number 8 and 9 on page 21. Let's see if we can get really comfortable with this, and then we can move on to more problems. Because this is really the only new material left, and we're just, the rest of the time, we're just going to kind of practice with word problems to get comfortable with those. Okay, so page 21, number 8 and 9. I'll put up a second. So I guess you could, for number 8, you could work your way down to finding all 3 sides and then do the formula for side, side, side. But I feel like getting the side angle side maybe is a little bit faster. But I mean, as long as you gather information, get the right answer, show your work, doesn't really matter. Any questions with 8? Okay, if you're good with 8, try number 9. Any questions with 9? Okay, I'll leave this up for a minute. We're going to do 2 more problems, so we'll move on just to do some word problems, but I just want to do 2 for today. Page 22, we're just going to do number 2 and 3. Okay, page 22, just number 2 and 3. I think we've done number 2 already in the past, but see if you can read the problem and just see if you're able to create the diagram. I think that's probably the hardest part of word problems, just trying to translate those words into a diagram. Because once you get that diagram in front of you, then it's just like solving for a problem that you've seen before. Right. So page 22, number 2 and 3. Any questions with 9? Anybody still need to look at number 9? Okay. Give you guys another minute, and then I'll go through and make sure you guys have the right setup. Okay, number 2 and 3 on page 22. Yeah, this is just. Got the mountain here. Okay, so let's read the problem here. Cable car transports the passenger up and down the mountain. So we're going to try to treat a mountain like a triangle shaped. Track used by the cable car has an angle of elevation 30 degrees. So it's going to move up the mountain, right? This cable car, just use rails here. And then the angle of elevation is 30 degrees along the side of the mountain. Right. The angle of elevation from a point 100 feet from the base of the track. So we're still on the ground, but we're going to move further away from the mountain, 100 feet. And then once we're 100 feet away, we're going to look up at the top of the mountain, and the angle of elevation is going to be 26.8. And now it says find the length of the track. So our focus, I'm going to highlight the triangle that we're going to be working with. It's going to be this triangle here. I'm going to just arbitrarily give these letters here. So angle, let's say A, B, and C. So really, you just have to solve this triangle, right? Use law of sines to solve for x. Yeah, the hardest part is translating those words into a diagram, right? But just to make sure that you guys can get started here, can we find this angle B easily? Yeah, that 30 is going to help us out, right? You got a linear pair here. So once you get that angle B, you should be in the clear. You should be able to then get to angle A and then law of sines, get to solving for x. Okay, any questions with 2? Okay, we'll just finish up with number 3. Number 3, it's side, side, side. You know, you can use law of cosines, but don't skip any steps. Start with the largest angle first, and then you can work your way down to the least or the smallest angle. So number 3 is just finding angle. There's no area formula involved with number 3. Just imagine that's a quiz question that you could have seen, number 3. Any questions with 2? Okay, we'll just finish up with 3, and I'm just going to come around and just check you guys off for your classwork, the homework tonight. Guys, as I come around, if you can just show me the work that we did, page 20, 21, and 22. I know you're working on 3, but just show me those 3 pages. Yeah, that's it. It's 20 to 22. Okay, here's number 3. I found angle B first, because that's the largest angle, and then I worked my way to the smallest angle. I know my smallest angle is going to be angle C, because it's across from the smallest side, 14.9. All right, we're just going to focus on word problems tomorrow, okay? So we've covered all the material that we need to cover, just practicing word problems for the next 2 days. Test on Friday. I hope to get back your quiz tomorrow, okay? A what? The review sheet will be on the last page, yeah. But if we get done with everything, maybe I'll come up with another one. Thank you.